Alright, part 2. Let's now talk about how to draw the Lewis structure for a water molecule. So again, we're going to start by listing our elements and noting how many of them we have. We'll then calculate our supply and demand totals. Again, supply is dealing with valence electrons. So oxygen normally will supply 6 valence electrons. Since there's 1 oxygen, that's a total of 6. Hydrogen, each hydrogen supplies 1 valence electron. Since there's 2 hydrogens, that's a total of 2 supplied. So overall, we have 8 electrons that our atoms are already supplying. Now demand. This is, what they would want to satisfy the octet rule. So oxygen, just like most other atoms, wants 8 electrons. Since there's only 1 atom of oxygen, that'll be for a total of 8. Now hydrogen, again, is an exception. It normally only wants 2. Here we have 2 hydrogens, so that's a total of 4. So a total of 12 electrons demanded. Now again, we're going to use these totals to figure out how many electrons we have to share, and therefore how many bonds we need to make. So if we take our demanded electrons and subtract our supplied electrons, that's going to get us a total of 4 electrons that must be shared. When we divide by 2, that tells us the number of bonds. So if we have here hydrogen and oxygen, we don't have carbon, so we can't start with it in the center. So we're typically going to arrange things so that they are symmetrical. So since we only have 1 atom of oxygen, it's most likely going to go in the center with the hydrogens on the side. So we know we have 2 bonds, so let's go ahead and place the 2 bonds going to either hydrogen. This will satisfy hydrogen's desires for 2. Now, up to now, we've used 4 electrons. But if you'll remember, we were already supplied with a total of 8. So that means we have 4 more electrons we need to place. Those 4 additional electrons will be placed around oxygen to satisfy its octet. Now oxygen has 1, 2, 3, 4 pairs of electrons, which makes for a total of 8. 1, 2, 3, 4, 5, 6, 7, 8. Because don't forget, each bond represents 2 electrons. Now, so far, we've just been dealing with single bonds. But let's see what happens when we can have more than just 1 pair of electrons shared. Like, what about a double bond or a triple bond? And so what we're going to see is that a double bond will look like 2 lines, and it's where we have 4 electrons that are shared. And a triple bond will look like 3 lines, and it's where we have 6 electrons that are shared. And again, this is a triple bond. All right, so let's do an example of CO2. So again, let's tally up our atoms. Carbon we have 1 of. Carbon will supply 4 valence electrons, times 1 is 4. Oxygen will supply 6 valence electrons, times 2 is 12. Add those up for a total of 16 electrons that are supplied. Now if we look at what's demanded, carbon normally demands an octet of electrons, times 1 carbon equals 8. Oxygen normally demands an octet, times 2 here equals 16. So as we're taking this into account, 16 plus 8 is 24 electrons. To find the number of bonds, we take 24 and subtract 16. This gives us 8 electrons. When we divide by 2, we see that we need to make 4 bonds. So again, because we have carbon in our formula, we're going to start by placing it in the center. And then for symmetry, we'll place an oxygen on either side. Now, because we have 4 bonds, I could do this, but that wouldn't work because we don't have 4 atoms. So that means that I'm going to have to form, instead, 2 double bonds. All right, so now I've used up my 4 bonds, and look, that actually satisfies the octet for carbon, 2, 4, 6, 8. So carbon is good. But if you'll remember, we had 16 electrons to work with. So that means we need to place the remaining 8. So we're going to place 4 on this oxygen and 4 on this oxygen in order to satisfy all of their octets. So now this oxygen has 2, 4, 6, 8, so it's satisfied. And likewise, this oxygen has 2, 4, 6, 8. So it's satisfied as well. All right, so that's all for tonight. In class, we're then going to go on to an example of NO2, where we have an extra electron thrown into the picture, and then we'll jump into the practice problems. All right, thanks for watching, guys.